Welcome back viewers. In today's video, we are going to check out what is Docker. So let us start. So Docker is an open platform for developing, shipping and running applications. Docker enables you to separate your applications from your infrastructure so that you can deliver the software quickly. With Docker, you can manage your infrastructure in the same way you manage your applications. By taking advantage of Docker's methodology for shipping, testing, and deploying the code quickly, you can significantly reduce the delay between writing the code and running it in production. So the Docker platform consists of the ability to package and run an application in a loosely isolated environment called a container. The isolation and security allows you to run many containers simultaneously on a given host. Containers are lightweight and contain everything you need to require to run the application, so you need not rely on what is currently installed on the host. You can easily share containers while you work and be sure that everyone you share with gets the same container that works in the same way. So there is a good amount of reproducibility in the containers. Docker provides the tooling and platform to manage the lifecycle of your containers. Develop your application and its supporting components using containers. The container becomes the unit for distributing and testing your applications. So when you are ready, deploy your application into your production environment as a container or as an orchestrated service. This works the same whether your production environment is a local data center, it is a public or a private cloud, or it is a hybrid of the two. So what are the applications I can use the Docker for? So you can do the delivery of your applications in a consistent and a fast way. So Docker streamlines the development lifecycle by allowing developers to work in a standardized environment using the local containers which provide your application and services. Containers are great for continuous integration and continuous delivery, that is CI/CD workflows. Consider the following scenario. Your developers write code locally and share your work with their colleagues using Docker containers. They use Dockers to push their applications into a test environment, execute automated and manual tests. When developers find bugs, they fix them in the development environment and redeploy them to the testing environment for testing and validation. When testing is complete, getting the fix to the customer is as simple as pushing the updated image to the production environment. So if you remember in the last video, uh, what are containers? I have told you that containers can be used by the developers to develop the application in a very fast and consistent way, and you can deploy your application in the development host. So you can have your laptop as a development host. You can create some containers and you can then test your application source code in the container. You can do multiple cycles, that is writing the code, testing the code, debugging the code, improving the code, and again testing the code. So you can do this cyclic process till the application is perfect, and then that same application can be migrated or exported to the production host on where the application will actually run, or you can export it to the customer host, customer server, or customer cloud, customer public cloud, or customer private cloud, where it will be actually running and uh, giving productivity. Now, responsive deployment and scaling. Docker's container-based platform allows for highly portable workloads. Docker containers can run on a developer's local laptop or on physical or virtual machines in a data center, on cloud providers, or in a mixture of environments. Docker's portability and lightweight nature also makes it easy to dynamically manage workloads, scaling up or tearing down the applications and services as business needs dictate in near real time. So you can scale up the dockers containers. So when, say, your application is running in a production environment, it might be a local data center, a server, a local cloud, private cloud, public cloud, whatever it is. And if you think that more and more users are using the application and you need to scale up, then you can easily scale up your application inside a docker, that is inside a container, and you can increase, say, the resources available to the container, and that way you can scale up and meet the customer demands. And you can do any changes if required to the application and redeploy it, so that it becomes more scalable and it matches the requirements of your customers. Running more workloads on the same hardware. Docker is lightweight and fast. It provides a viable, cost-effective alternative to hypervisor-based virtual machines, so that you can use more of your server capacity to achieve your goals. Docker is perfect for high-density environments and for small and medium deployments where you need to do more with fewer resources. If you remember, we had done a comparison between a container and a virtual machine. So container does not have the underlying operating system like in a virtual machine, and it doesn't even have the kernel. So that way there is less code to execute in a container, and that is why the container is faster. Only the application and its related dependencies run inside a container, while in a virtual machine the application and its dependencies along with the host, along with the this virtual machine kernel and OS will run on a host OS. So there are two OSs, two kernels, everything is double. Plus the application and dependencies are there. While in Docker, only the host OS, host kernel is there. On the top of that, the container works, and inside the container, only application and its dependencies are running. So it reduces the code that is being running on your hardware resources, and that's why it speeds up the application and speeds up the whole cycle of usage. Now Docker architecture. Let us take a look at Docker architecture. So while we see the Docker as a diagram, we will understand it in a more better way. So Docker uses client server architecture. The Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker container and the Docker client and daemon run on the same system, or you can connect a Docker client to a remote Docker daemon. So remote connection and remote working of any of the either the client or server is possible. The Docker client and daemon communicate using a REST API or Unix sockets or a network interface. Another Docker client is Docker Compose, that lets you work with application consisting of a set of containers. Now let us understand this diagram. In the client, you will have the terminal and you can execute the scripts to manage your Dockers. So the first script, for example, let us pick up this Docker build. So using this script, you will build an image of the Docker. So that script will communicate with the Docker daemon, and the Docker daemon will then help you to build your image, Docker image, and that Docker image will rest in the registry. And when you use the docker pull command, it will pull that image created and it will be deployed in one of the containers. Similarly, if you use the docker run command, what will docker run will do? It will first pull and then it will run the same the pre-configured image from the registry inside the container, chosen container. And what is the nginx? So here you can see nginx. So nginx is nothing but a web server. If you can see, it is an advanced load balancer and a web server and a reverse proxy. So whenever you got multiple containers running, you require to balance the load. So it is a load balancer, it is also a web server. So in one of the videos, we will check out what is the MGINX, how it works and everything. So it is a web server. There are some docs. There is an application server also. So you can maybe deploy the applications using this on, and that applications will run on the containers. So something like that will be there. So for that we will have to go in much greater depths, but we will just stick with the basics right now. So Docker build will allow you to build custom images that will be stored in the registry. Docker pull will pull that image from the registry and it will be deployed in the container. And in the Docker run, you will pull as well as run the pre-configured image that you have configured using the Docker build, and it run in the container. So there can be multiple containers and you can have multiple pre-configured images, or you can even have some standard images, and those can be deployed in a container using the Docker pull and Docker run command. So this is how the schematic or the working of Dockers happens. So it is three part. One is client, there is the Docker host, and the third is the registry. So all the three work together to make the applications run and make the customer productivity or give productivity to the customer. So we will now proceed ahead. Now the now the Docker daemon, that is doc rd, run docker d or doc erd listens to your Docker API request and manages Docker objects such as images, containers, networks, and volumes. So any of the images, containers, networks, and volumes running inside is called a Docker object. A daemon also communicates with other daemons to manage the Docker services. Now the Docker client. Docker client is the primary way that many Docker users interact with the Docker. When you use commands such as docker run, that client sets the commands to the docker d, which carries them out. The Docker command uses the Docker API. The Docker client can communicate with more than one daemon. So here you can see this Docker host will contain multiple Docker daemons. Your client can be one or many, and using the command line interface and this commands Docker build, pull, and run, it can manage the different Dockers containers running in the Dockers. There can be multiple Dockers and multiple images will be running uh, inside the containers. So the containers, different containers will have different images. Now the Docker desktop. Docker desktop is an easy to install application for your Mac, Windows, or Linux environment that enables you to build and share containerized applications and microservices. Docker desktop includes the Docker daemon, that is the Docker D, the Docker client, that is the Docker, and the Docker Compose, Docker Content Trust, Kubernetes, and the Credential Helper. For more information, you can check out this link. Now, what are Docker registries? A Docker registry stores the Docker images. A Docker Hub is a public registry that anyone can use, and the Docker is configured to look for images on a Docker Hub by default. You can even run your own private registry. So there are two types of registries, private as well as public. Public registry is that registry which anyone can use, and private registry is private only to a group of users or to an individual user. When you use Docker pull or Docker run commands, the required images are pulled from your configured registry. When you use the Docker push command, your image is pushed to your configured registry. The Docker objects. When you use Docker, you are creating and using images, containers, networks, volume, plugins, and other objects. This section is brief overview of those some of those objects. Now, image. An image is an read-only template with instructions for creating a Docker container. Often an image is based on another image with some additional customization. For example, you may build an image which is based on Ubuntu image, but installs the Apache web server and your application, as well as the configuration details need to make the application run. You may create your own images, or you may use only those created by others and published in a registry. To build your own image, you need to create a Docker file with the simple syntax for defining the steps to create the image and run it. Each instruction in the Docker file contains the layer, creates a layer in the image. When you change the Docker file and rebuild the image, only those layers which are changed are rebuilt. This is part of what makes images so lightweight, small, fast, as well as compared to other virtualization technologies. So when you are using an image to deploy as a virtual machine, that image is quite heavy because it contains the almost complete operating system, kernel, and a host of different applications which may or may not be directly required by the user, but it is there because it is a standard image. So for example, if you try to run a Ubuntu virtual machine, that Ubuntu virtual machine will contain the OS, the kernel, with many different applications, but you might not require all those applications in that particular instance of the virtual machine, because you might want to use a specific feature or a specific application in your virtual machine. So it is quite bloated. You don't require many of the things, but they are still there because the standard Ubuntu image will contain everything, because it is just made standard, one size fits all kind of methodology is there. But here in Docker, you can create the specific image based on your requirements. So if you want Apache web server to be installed, it will be there. You have to build your Ubuntu image along with the Apache web server. If you don't want Apache web server, if you want some other web server, say you want ISS web server, you will install that IIS web server. You will install that. If you want say a database server, you will install a database server along with your Ubuntu. So your database server will work in the Ubuntu container based on the image that you have created. So you everything can be modified as per the requirements, and that image will exactly fit your requirements. So all the bloatware, what is not necessary, all the applications, the kernel OS is booted out, only the application, its dependencies, and some of the some of the code required for the functionality of the container is only present. Now containers, a container is a runnable instance of an image. So you can create, start, stop, move, or delete a container using the Docker API or the command line. You can connect a container to one of more networks, attach storage to it, or even create a new image based on its current state. By default, a container is relatively well isolated from other containers and its host machine. So you can control how isolated a container's network, storage, and other underlying subsystems are from other containers or from the host machine. A container defined by its image as well as the configuration options you provide it to when you create or start it. When a container is removed, any changes to its state that are not stored in a persistent storage disappear. So there is one example given. The following command runs in Ubuntu container, attaches interactively to your command line session and runs the bin bash. So docker run -i -t Ubuntu /bin/bash. When you run this command, the following happens. Assuming you are using the default registry configuration, you do not have Ubuntu image locally, Docker pulls it from your pre-configured registry as though you had run the Docker pull Ubuntu manually. Docker will create a new container as though you had run the Docker container create command manually. Docker allocates a read-write file system to the container as its final layer. This allows running a container to create or modify files and directories in its local file system. Docker will create a network interface to connect the container to the default network since you do not specify any networking options. This includes assigning an IP address to the container. By default, containers can connect to external networks using the host machine network connection. So just like a virtual machine, it can by default connect to the external networks using the host machine network connection. Docker starts the container and executes the /bin/bash. Because the container is running interactively and attached to your terminal, due to the -i and -t flags, you can provide input using your keyboard. So -i is your input and the output is -t, while the output is locked to your terminal. So your output will be given to the terminal. You can see the output in the terminal. -t is the terminal, -i is the input or the keyboard. When you specify exit to terminate the bin bash command, the container stops but it is not removed. You can start it again or remove it. Now what is the underlying technology in the Docker? So Docker is written in the Go programming language and takes advantage of several features of Linux kernel to deliver its functionality. Docker uses a technology called namespaces to provide isolated workspace called a container. When you run a container, Docker creates a set of namespaces for that container. These namespaces provide a layer of isolation. Each aspect of the container runs in a separate namespace and its access is limited to that namespace. So there will be unique namespace for a unique container, I think. This is what I am understanding. So let us read it again. These namespaces provide a layer of isolation. Each aspect of a container runs in a separate namespace and its access is limited to that namespace. So each aspect, or it is a container running in a separate namespace. Each aspect, I think the whole container will run in a separate namespace maybe, and its access. So we will see when we do some actual experiment and create a container using Docker. That time we will see how it things work out. And now the next steps are installing the Dockers and getting hands-on experience, getting started with the Docker tutorial. So with this, I will stop the video here. We have learned in short what are Dockers, how the Dockers are used, what are the features of the Dockers, and we saw one diagram also. So that is good enough to start with. So I will stop the video here. In the next video, we will check out what is Podman or what are Podman. So how to use Podman. So Podman, and then we will also check out what is the difference between Podman and a Docker. So which is better? Not exactly which is better, but which provides which feature set. So there is a difference between the Podman and Docker feature set. So that we will discuss in the next video. See you in the next video. Bye bye.